This is Manganese Delta, Matt Morabito and Jamie Poland, anchoring verbal modeling. Verbal modeling is a way of describing and understanding a process control system. We will now run through the verbal modeling process with a sample situation using fictitious values. Vaporized product enters a condenser, is cooled by cooling water, and leaves as a liquid. The liquefied product is stored in a jacketed tank where refrigerant is used to keep the temperature low and the product liquefied. The liquid product can be sold for $6 a gallon. The cooling water is provided by the plant and the exiting water stream is fed to a pond, so cannot exceed 35 degrees Celsius to avoid damage to the habitat. The refrigerant is recycled from another process and can be used again elsewhere. The storage tank has a maximum pressure of 5 atmospheres and a volume limit of 5,000 gallons. In order to begin the verbal modeling process, we will first describe what is going on in the system. The purpose of the process is to condense the product stream using a condenser and cooling water stream, and then to store the liquid product in a refrigerated storage tank. The main objective of the process is to obtain the liquefied product to sell at $6 a gallon. The constraints are the storage tank volume limit, the storage tank pressure limit, and the exiting water stream temperature limit. The major disturbances of the system could be fluctuations of the ambient air, feed, cooling water, and refrigerant temperatures, as well as changes in the flow rate.
In this system there are 4 sensors. One is a temperature sensor on the exiting water stream. The other 3 are temperature, level, and pressure sensors on the liquefied product storage tank. These sensors control 4 control valves on the feed inlet, the cooling water inlet, the refrigerant inlet, and the pressure release valve on the storage tank. After performing a degree of freedom analysis, the result is that there are 0 degrees of freedom in the system. In this process, cooling water will remove the heat from the product stream, condensing it. Refrigerant will keep the temperature of the liquefied product low enough to store. The 4 valves from the system control 4 different parameters, including the flow rate of the product, the temperature of the outlet cooling water, the temperature of the liquefied product, and the pressure inside the vessel. These valves will react to different disturbances and will change the parameters in order to make the process go back into within its restraints. In this process, we have totally neglected accumulation and loss of material. This condenser is fully controlled with the valves on the inlet stream controlling the temperature and the flows of the product and cooling streams. Since this product has 0 degrees of freedom, it is not possible to optimize it further. This has been an example of verbal modeling in a process control system.